All right, today we will at least start section 4.4. Our goal is going to be to find powers of monomials. So taking a monomial and raising it to a power or giving it an exponent. We've already seen this a little bit when it comes to numbers. So on the first warm-up, -2 to the third power means that we're going to take -2 and multiply it by what? -2 and -2. So our exponent tells us how many times we're multiplying whatever's in parentheses to itself. Because the negative sign was in parentheses with the 2, it belongs to the 2. So that's why we keep writing it as a negative. All right, so then all we have to do is multiply those together to get our answer. What is it, Ellie? -8. So that's the answer to the first warm-up. The second warm-up is a little bit trickier. It's the same idea, though. We've got something in parentheses raised to an exponent. So we've got -b to the fifth power. So we have -b times -b. How many times? 5 times. 1, 2, 3, 4, 5. 5 negative b's multiplied together. So one thing that we have to pay attention to is what our sign will end up being. And the other would be what we're going to do with this b that we're multiplying out 5 times. So Keon, what do you think the answer is? Just -b? I think you're close. Let's talk about how we would come up with this. So I said the first thing we need is our sign. So let's go through this a little bit at a time. A negative times a negative means that would come out to be a positive, and b times b would give us b to the what power? Second, or b squared. Okay, and we do that again here. -b times -b. A negative times a negative is a positive. B times b is b squared. We're still multiplying these things together. This last one on the end doesn't have somebody to multiply to just yet, so I'm going to bring him straight down. Okay, so again, if you want, we can do this one step at a time. If I take b squared times b squared, what do I get? B to the 4th. And then we're still multiplying it by that -b. What number could I put in front of the b to the 4th? A 1. And what number is in front of that -b? A -1. A positive times a negative is a... I should hear that a little bit louder. A positive times a negative is a negative. So we know our answer will be negative, and b to the 4th times b is b to the 5th. So our answer ends up looking an awful lot like the original problem. However, there's no parentheses. I don't know if it's a rule that we will ever actually state in writing. However, if you are raising a negative, either number or a negative variable, to an odd power, like 3 or 5, your answer will come out to be negative, which we can kind of see here when we paired them up. A negative with a negative multiplies to a positive, but then you have an odd man out. Anytime you have an odd number, you'll have an odd man out when you pair them up, which will end up turning your answer negative. All right. On this third one, we are asked to find the missing exponent. Does anybody think they found it? Jakeem? 3. How'd you come up with 3? And what do you know you have to do with those exponents? Add them. So we know we had to add the exponents up to equal 8. So 3 plus 5 is how we would come up with 8. Good. All right, our first rule of the day. Rules of exponents for a power of a power. For all positive integers, m and n, a to the m raised to the n is equal to a to the mn. What is happening between m and n when we write them right next to each other? We're multiplying them. So if you want, you could write it as m times n if you want to put the dot in there to make it obvious, or use parentheses around one of them to make it obvious. Okay, we are multiplying. So that little note says to find a power of a power, you multiply the exponents. So an exponent raised to another exponent, we multiply. Our next rule is for the power of a product. Product means what? What operation are we doing if we're finding a product? Multiplication. Okay, so this is if you're taking a multiplication problem and raising it to a power. For every positive integer m, a times b raised to the m is equal to a to the m times b to the m. Again, if you want, you can put a multiplication sign in between those to make it obvious that those two terms are still getting multiplied together. To find a power of a product, you find the power of each factor and then multiply. So the factors being a and b in this case. You give that exponent to every factor. All right, on example 1 through 3. Do we think this is going to be like the top box or the second box? The top. We are taking a power and raising it to another power. An exponent raised to an exponent. If we have a power raised to a power, what are we told to do with the exponents? Multiply them. So on example 1, we are going to take 3 times 4 and we would get 12. M to the 12th. That's it. All we got to do. Power to a power, we multiply. Anybody want to tell me what they think we would get on number 2? Natalie? X to the 10th sounds wonderful. 2 times 5 would give us 10. Now on that last problem, I would start with your order of operations. So our order of operations tells us to start on the inside of parentheses or grouping symbols. So the first thing I think we need to take a look at is negative b to the 4th power. Okay, so let's first just take a look at what that means. Negative b times negative b times negative b times negative b. Now from our warm-ups, you might have an idea of what that's going to come out to be. Do we think it would come out to be positive or negative? Positive, good, because we can pair up those negative signs. A negative times a negative is a positive. Negative times a negative is a positive. So we would end up with positive b to the 4th power. If we add those exponents, 1 plus 1 plus 1 plus 1, that gives us b to the 4th. So that turns this problem into b to the 4th raised to the 5th power. So we're simplifying it from the inside out. Questions about that first step? All right, then we have to evaluate b to the 4th to the 5th. A power to a power means we are going to multiply our exponents. Ellie, what do we get? B to the 20th. All right, the next couple examples. Does this look like the top box or the second box? Second box. Okay, we've got multiple things inside parentheses, all of it getting raised to an exponent. When that happens, the exponent is given to each factor. So how many factors or pieces do we have inside the parentheses on example 4? I heard one person whisper it. How many factors do we have inside the parentheses? How many things are getting multiplied together? 2. Okay, we've got 2 times a y. So we've got 2 pieces or 2 factors in those parentheses. Each factor gets the exponent. 2 to the 4th times y to the 4th. Which of those pieces can we actually evaluate more? 2 to the 4th power. We could multiply that out. 2 to the 4th would be 2 times 2 times 2 times 2, which would give me 16. So 16y to the 4th. If you want, you can keep the dot in between them if that makes you feel better, but you don't have to have it there. All right, on number 5, how many factors do we have in those parentheses? How many different things are getting that exponent? 3. What are they? -4, m, and n. If you are raising a negative to an exponent, I would keep it in parentheses to remember that the whole thing, including the negative sign, gets that exponent. We've also got m to the 3rd and n to the 3rd. Questions about that first step? Every factor gets the exponent. Okay, then we have to keep simplifying what we can. What can get simplified more here? -4 to the 3rd. So -4 times -4 times -4 is -64. The m cubed and n cubed cannot be simplified anymore because we don't know what m and n are. Also, why can I not combine the m and n's exponents? Not the same base, not the same variable. So we got to leave it like that. All right. This next slide makes it even more interesting. How many factors are inside the parentheses on number 6? One person thinks they know. Couple people. 3. There are 3 factors in those parentheses. What are those factors? 4. What else? A cubed and b squared. If you want, you can put parentheses around all of them. I would at least put parentheses around ones that already have exponents. So each one of those factors is getting which exponent? The 4 from the outside. So 4 raised to the 4th power, a cubed raised to the 4th power, b squared raised to the 4th power. Every factor gets the exponent. Now we are actually able to simplify each of these pieces. First thing we have to do is take 4 to the 4th power. What is 4 times 4 times 4 times 4? 256. How are we going to simplify a cubed to the 4th power? Good. A power raised to another power. We have to multiply the exponent. So we get a to the 12th. Same thing with b squared to the 4th. A power to a power we multiply. We get b to the 8th. I want you to try number 7 on your own real quick. And then we'll talk about it in just a minute. Kelby said he got 9. My 9's not very neat. 9 p to the 6th, q to the 8th. I would agree with that. If we give that exponent outside the parentheses to each part, we would have 3 squared times p cubed squared times q to the 4th squared. Okay, a number raised to an exponent we can evaluate. 3 squared is 9. A power raised to another power. What do we do with those? Multiply them, so we get p to the 6th. 4 times 2 gave us q to the 8th. Questions about 7? All right, we'll keep it moving then. Numbers 8 and 9, we are also going to start pulling in our rules from 4.3. So we've got our rules from today, but we're also going to start applying our rules from last week. So the first thing to do is to deal with these exponents that are outside of the parentheses, just like we were doing on the last couple examples. So inside the first parentheses, we have a 3 and we have an x cubed. Both of those are getting which exponent? The second, squared. Okay, that exponent right out there. Then, if you want, you can put a big times symbol in between them. Then we have to deal with the second set of parentheses. Inside that parentheses, we've got a 2, and we have an x, and both of those are getting which power? The 4th power. Okay, again, you can put multiplication signs in between all of them if you want to. We've got to start simplifying this a little bit at a time. Before we start doing that, do we have any questions about how we built this part of it? All right. Logan, tell me one thing I can simplify here. You can start in the front of it. You can start in the middle of it. I need one thing that can get simplified from what I wrote. 3 squared could be simplified to be what? Logan, what's 3 times 3? 9. 3 squared could be simplified to be a 9. So I'll replace that there. Jeria, what's something else I could simplify here? What other one? This next term, x to the 3rd squared? Yeah. Good. What do I do with those exponents? Multiply them, so I get x to the... No, we're just multiplying them, so 3 times 2. Good. All right, so we can replace the x cubed squared with x to the 6th. The power to a power, we multiply them. Ryan, what else can we simplify here?
The 2 to the 4th power.
Good. What's 2 to the 4th power?
16.
16. Good. Right now, there is not a way we can just simplify the x to the 4th, so I'll leave it as x to the 4th. Again, if you want, you can have multiplication dots in between all of these. You could use parentheses. Whatever it is, you have to know that what we're doing is multiplying. So there are still 2 more things we can do to simplify. Delaney's not here. May, what's something I can do to simplify now? 9 times 16. Good. What is 9 times 16? Sorry. 144. Okay, thank you. All right, the last thing I can do to simplify, Tariana. So I would be careful with that. We are multiplying x to the 6th times x to the 4th. But Tariana, if we're multiplying the same base, what do we do with those exponents? Add them. So we get x to the 10th. That's that rule from Friday coming back. Okay, we're multiplying the same base. We have to remember to add the exponents together. And there's our answer. Questions about number 8. I would recommend taking these problems one step at a time. All right, on number 9, we are going to set it up the same way. Every term inside the first set of parentheses is getting which exponent? The 3, the cubed. So that means I'm going to have 1/10 to the 3rd power. I'm going to have x cubed to the 3rd power. And I'm also going to have y to the 3rd power. Everything inside that second set of parentheses is getting which power? The 4th power. So that gives me 10 to the 4th power and y to the 4th power. Let's go through one piece at a time and simplify what we can. If we have 1/10 to the 3rd, I'm going to write that out down at the bottom here. That would be 1/10 times 1/10 times 1/10. When we multiply fractions, we multiply straight across the top, straight across the bottom. 1 times 1 times 1 is 1. Okay, 10 times 10 times 10 is 1,000. So we end up with 1 over 1,000 when we simplify 1/10 cubed. Times Jaquan, when we take x cubed cubed, what do we get? X to the 9th, good. We take a power and raise it to a power, we multiply them. All right, there's nothing we can do with y cubed. It's just going to have to stay y cubed for right now. We can do something with 10 to the 4th. 10 times 10 times 10 times 10, what do we get? 10,000. And then again, on the end there, y to the 4th cannot change right now. We have to keep simplifying. We can take 1 over 1,000 and multiply it by 10,000. Does anybody know what we get? Ellie? 10. Let's keep on building our answer. Is there anything to multiply with or simplify the x to the 9th? No, there are no other x's there. So x to the 9th comes down. We can multiply y cubed times y to the 4th on the end. Ellie, what do we get? Thank you, Ellie. Y to the 7th. If we are multiplying the same base, we add the exponents. 3 plus 4 gives us 7. Questions about number 9? Okay, we'll keep it going. 10 and 11 ask us to evaluate given certain values for our variables. Anytime we evaluate, what's the first thing we should do? Plug them in, substitute. So we've got 3 times 2 cubed. by our order of operations, where should we start? In parentheses. Inside the parentheses, what's happening with this 3 and this 2? Multiplying them. 3 times 2 is 6. And then we have 6 raised to the 3rd power. 6 times 6 times 6 is 216. Good. All right, on our next problem, we plug them in. 2 times negative 4th cubed. Is that cubed getting applied to both the 2 and the negative 4? Does this cubed belong to both the 2 and the negative 4? No. Okay, it only belonged to the y from the beginning, so it only belongs to the negative 4 now. So based on our order of operations, is there anything to do inside of the parentheses? No. Inside of parentheses, we either just have a 2 or we just have a negative 4. What's our next operation? After parentheses comes exponents. So we need to apply our exponent next. That means the 2 is staying there for now. Negative 4 to the 3rd power gives us I think I disagree with that. Negative 4 times negative 4 times. Good, negative 64. And then we can do our multiplication and we get Ryan?
Negative 128.
Negative 128. Questions about evaluating with exponents? Okay, we'll keep it moving. We've got a couple more evaluate problems. First step should always be to substitute. So this time we have 3 squared times 2 cubed. So I'm still just plugging in whatever they tell me to for my variables. Nevaeh, what is 3 squared?
We on 12, right?
Yep.
Okay. When we said answer?
I asked you what 3 squared is.
I don't know what you mean.
What is 3 times 3?
Oh, 9.
Okay. Times, Jamarl, what is 2 cubed going to give me? What is 2 cubed going to give me? 2 times 2 times 2? 8. Last step is going to be to multiply those together. Danielle, what do I get as my final answer? Thank you. We substitute and then we simplify. We have to use our order of operations. That's why I did exponents, both of the exponents, before I did any multiplication. Number 13, again, inside those parentheses, we've got both x and y. Order of operations says to start inside of parentheses if we can. In this case, we need to take 2 times negative 4. Deshaun, what does that give me? Negative 8. And then I have to evaluate negative 8 squared. Lexi, what does that give me?
64.
Thank you. And then we're done. Substitute, simplify using your order of operations. All right. Our next rule is going to be the quotient properties of exponents. Quotient meaning what kind of problem? Division. Our quotient properties should hopefully be easy to remember if we understand our multiplication properties. The first one is quotients of powers. If you have b to the m divided by b to the n, so now we're dividing the same base, we are going to subtract the exponents. The first one minus the second one. That rule is already written out for you. You just need to fill in the rest of this example. If we take x to the 7th divided by x to the 4th, to get our answer, we're going to take x to the 7 minus 4, and we get x to the 3rd. 7 minus 4 gives us 3. Okay, if we are multiplying the same base, we add the exponents. If we are dividing the same base, we subtract the exponents. Also, the power of a quotient rule, that next rule, is also very similar to the power of a product. For the power of a quotient, you're going to give the exponent, in this case they set it up as a fraction, to both the numerator and the denominator. Okay, both the dividend and the divisor, if you prefer it that way. The exponent gets given to the top and the bottom. So on that example that they wrote out for us, the 2x in the numerator gets cubed, and the 3 in the denominator gets cubed. Now what's interesting about this problem that they gave us for an example is that now we have a product raised to a power, which means we can keep applying our rules. The 2 gets cubed and the x gets cubed. The 3 is still getting cubed in the denominator. We can simplify 2 cubed and 3 cubed. We just talked about 2 cubed. What is it? 8. What about 3 cubed? 27. So that one we were actually able to apply a new rule and another rule that we'd already learned today. All right, your homework is on page 156, numbers 1 through 31, odds. 1 through 31 odds.